Okay, so we're gonna finish up the rest of the modeling. So if we look here, on this one we do have a horizontal line. So remember, whenever we have a horizontal line, okay, our slope is 0. Okay, so here our slope here is 0. Even if you wanted to count your rise over your run, I know it's kind of hard to see the line right here, but it's right here. You can see the little arrows. And so if you notice our rise, it doesn't go up any, it's 0. And our run, we can even count maybe 1 or 2 or 3 or 4. So 0 over 4 is going to give you 0. Okay, or 0 over any number. So that's why our slope is 0. Remember, it makes the letter Z. Okay. Then our B is our y-intercept. So let me erase this big mess I made. Okay. Where does it cross the y-axis? That's what you need to ask yourself. So it crosses my y-axis at -4. So my B is -4. Okay. So then my equation of my line is going to be y equals mx plus b. I'm going to rewrite the equation right here. Y equals mx plus b. But you're going to substitute these values. So you're going to substitute 0 for m, and then you're going to substitute -4 for b. Okay. So when I write this, it's going to be y equals 0x, and then instead of being plus b, because it is a negative, it's going to be -4. Okay. And then just a little reminder, 0 times x is just 0. Okay, it's nothing, so it's going to give us -4. Y equals -4. All right, the next one. Okay, so here we have another line. If we notice, it does cross the y-axis at +3, so that means our b is 3. And then our m is our slope. So here we're going to count the rise over the run. So I'm going to take these 2 points. Okay. And this time it goes down. So it goes down 2, so it's going to be -2. And it goes to the right 1, 2, 3, 4, and 5. So our slope here is -2 over 5. So when I write this in the form of y equals mx plus b, instead of m, we're going to put -2 over 5 x, and then b is going to be 3, so plus 3. Whoops. Okay, and then this next one. So this one, if you notice, it does not cross the y-axis at all. In fact, it's a vertical line that goes straight up and down. Okay, so here our slope, I'm not going to write it just yet. Our y-intercept does not exist. We do not have a y-intercept. So here I'm just going to write none. Okay, and for our m, here it rises. It just continues to rise and rise and rise, but it doesn't run any. So say I count these spaces, 1, 2, 3, 4 to the next one. Okay, but it doesn't run any. It's 0. So whenever you take a number and try to divide it by 0, it gives you undefined. Now remember, if you recall, your vertical lines are undefined. Okay, so m is undefined. So whenever you have a vertical line, you're going to go ahead and see, okay, it goes through my x-axis. Well, it goes through my x-axis at -4, so then that means that my equation is x equals -4. Okay, so if you notice on your vertical line, your horizontal line, it went through my y-axis at -4, so that's why we put y equals -4. Okay, so now our applications. Okay, this is the last section. So here it says the Sandia Peak Tramway in Albuquerque, New Mexico travels a distance of about 4,500 meters to the top of the Sandia Peak. Its speed is 30 meters per minute. So since we see 30 meters per minute, this is our rate of change. Now remember, it's 300. Our rate of change is the same thing as our slope. Okay, so here, the function f of x equals 4,500 minus 300x gives the tram's distance in meters from the ground after x minutes. Okay, and then the distance is about 4,500 meters. That's where we begin. We're starting at 4,500, and then slowly we get closer and closer to the ground. And so that's why we see our graph. It does have a negative slope. They already gave us the table as well, so we don't have to make a table. We just got to interpret this information. So it says, what does an independent quantity represent? Okay, so here we have x and y. So x and y, they went to the doctor. And when they went to the doctor, they needed their ID. So that's what you need to remember. Okay, now x stands for domain. Domain. The I stands for independent. That's our independent variable, okay? Because it doesn't depend on anybody. Our R is our range, okay, which is our Y values. And D stands for dependent. Okay. So now from there, it's asking what does the independent quantity represent? So our independent quantity is going to be our X value. So if I look here on my X-axis is time. So my independent quantity is my time, and it's in minutes. Okay. And then it says, what does the dependent quantity represent? So our dependent quantity is going to be our Y value here. It says dependent, so this is going to be my dependent. Okay, and so my dependent is a distance from the ground, and it is in meters. Distance from the ground. All right, so then the next part says, what is the slope or the rate of change? So the slope or the rate of change is going to be this number that's being multiplied by x. I had already told you guys previously in the problem, it's minus 300, it's negative 300. If you're not sure, you can go ahead and look at the graph and we can count the rise over the run. So here's where it starts, okay? And then we find another point here on the graph, which looks about right here maybe, okay? And so this is counting by 500s. So if I go down, this is 500, 1,000, 1,500, 2,000, 2,500, and 3,000. So this is 3,000. And then our run, it's counting by 2. So 2, 4, 6, 8, 10. So if I take 3,000 and it's negative 3,000 because it is dropping, and we divide that by 10, that gives me 300. So our slope or our rate of change is negative 300. And what does it represent? Remember, our rise over our run. So our rise here, it tells us is the distance from the ground. So it drops 300 meters. And then per, and then our time is in minutes, okay? So per minute. Okay, it also tells us up here, its speed is 300 meters per minute. Okay. So the next part is, what is the y-intercept? So our y-intercept here, where it crosses a y-axis, is 4,500. And what does it represent? It's where we begin. Remember, the y-intercept is our b. It's always where we begin. So this is where we started, okay? That means that this is at the very top of the mountain. So the top of the mountain. Okay, and then slowly it just drops and gets closer and closer to the ground. Okay, it says, what is a reasonable domain? So remember, your domain is your x values. Okay, so my domain is going to be from 0 all the way up to, they don't give us this number here. It's between 4 and 16. So I'm going to say between 0 and 15. We put the x in the middle, and we put the less than equal to signs. Okay, because we can be exactly at 0 minutes, or we can be exactly at 15 minutes. All right, the next one is going to be, what is a reasonable range? Okay, so we're going to see our range, just in case you forgot, our range is our y value. So we're going to see how low does our graph go. So my graph goes as low as 0, and the highest that it goes is right here at my y-intercept, which we said was 4,500. So between 0 and 4,500. Okay, now we put the y in the middle, and that's it. So the next one says, find f of 10. So remember, when they put it like this, f of 10, that means when x is equal to 10, what is my y value? That's what we're looking for. So then I'm going to go ahead. I'm going to do it in different colors so you guys can see. This is where x is equal to 10. We go up to our graph, and then once we hit our graph, we go directly to our y-axis to see what this number is. Well, it's going to be a number between 1,000 and 2,000. So right in the middle, that is going to be 1,500. Okay, so explain your answer, okay? Well, if it says x equals 10, x equals 10 is time in minutes. So it means after 10 minutes, This tramway is 1,000. So the tramway is 1,500, and then it's in meters above the ground. Above the ground. Okay. And the last part, it says, what is f of x equal to 3,000? Write your answer in a complete sentence. So this one is saying, if y equals 3,000, okay, what is my x value? So on my graph, I'm going to find 3,000. I'm going to go ahead and go straight to the graph. Once I hit the graph, I'm going to go straight down. It's going to be between 4 and 6. So I'm going to say my x is equal to 5. Okay. Now the 5, remember, is time in minutes. So after 5 minutes, the tramway is 3,000 meters high. And that's it. So go ahead and get your assignment complete. Remember, you have to turn in everything to the substitute at the end of the period. Okay, thanks guys. Bye.